And so this is where we are now. And we're going to do this slide together. Okay, so you do want to have your Pear Deck open, and you should be on this side. I'm going to stop student pace because I do want you to be on slide 7 specifically. And so this is the general rule here, x to the a over b, where a over b is the exponent, is a rational number here. It's written as a fraction. And so what we're going to do to turn it into a radical expression is you have a numerator and denominator. The denominator, just like before, is still going to become the index. That hasn't changed. But now that our numerator is not just 1, even if it was 1, this rule works for when it's 1 as well. It becomes the exponent as the radicand's exponent here. Okay, the problems we looked at on Monday, this was a 1, so we didn't even write it, but now we're going to have a different number here besides 1, and we'll see how that affects our answers as we go through these. All right, so example 2, simplify expressions with fractional exponents, and we're going to look first at this one, 27 to the 2/3 power. Okay, and so 27 is the base, 2/3 is the exponent. We're going to use this rule here to simplify this expression. So we're going to turn it into a radical and then simplify. So we're going to use the definition, a to the m over n or x to the a over b. It's the same thing, just different letters in those places. And so the denominator, let me kind of match the colors that you see here. So our denominator, which is 3, goes here, right? See that? And that happened over here. The denominator was in the bottom of the fraction, became the index. And then our numerator, that number you see here, is going to become the exponent. Okay, and so now we can rewrite this as a power. Basically, 27 is equal to 3 to the 3rd power. So we're changing the 27 to the 3 to the 3rd power. Okay, and then what we're going to do is in the parentheses here, the cubed root of something being cubed, or the 3rd root of something to the 3rd power, it cancels each other out. And so we're left with just the 3. And then the squared symbol comes here. 3 squared is just the same as 3 times 3, and that's where the answer of 9 comes from. Okay, and so now we're going to do this next one together. 25 to the 3/2 power. So we're going to use the definition of a to the m over n, which means I'm using the rule where the denominator becomes the index and the numerator becomes the power. Okay, and so because of that, here's 25 to the 3/2. 2 is the denominator, and remember guys, when your index is 2, that's a square root. We don't typically have to even write the 2. We can write it just to kind of show you that, you know, you can. It's not wrong if you write a 2 here. You could put it there, but typically you don't write it. And then the 3 is going to end up right here. All right, so this is what you should write so far. You have the 2 here and the 3 here. This 3 is not changing, so that's staying here, just like that. And now what we're taking is this piece, and we're going to rewrite it. So the 2 is still here, but I'm rewriting 25, and I want it to match. I want to be able to eliminate this radical, so I want to match it to the index. So I want to think, what can I rewrite 25 as so that it's something squared? So you just have to think about your powers, your perfect squares. 25 25 is equal to what squared? What would my base be here? Is the unknown. Yeah, Kobe, you're right. It would be 5. Okay, so we're going to put a 5 as the radicand. Okay, 5 squared is the same as 25, so I'm rewriting 25 as 5 squared. And now this squared root that is squared here, these cancel each other out, okay? And I'm left with 5, and then this 3 has now shown up here. So definition of the, what root did we use? What do you call this root specifically in this picture? What should I put in this box? What root is that? Square root. So when the index is 2, it is called a square root. If the index is 3, it's called a cube root. This is a square root. Okay, and then 5 to the third power, what is that even equal to? So 5 to the third power is the same thing as 5 times 5 times 5. You guys agree with Kobe? Is it 125? Yeah, it is. Definitely. Good, Geo. It is 125. Okay, so my answer here is 125. Okay. I think I don't really like how, see how this radical comes over the exponent, but then we're not really doing that. So what I want you guys to do is on this slide, get the pencil tool and pick the color white, and just kind of erase a little bit of that because it's kind of weird that it's doing that. I want the exponent like further out. So you even put a pair of parentheses around it like we did here to kind of show exactly what we did. So you could put a pair, like a parenthesis here and a parenthesis here. Then that's a little more accurate to what we're doing to the right of it. Okay, so I just kind of edited that a little bit. Yeah, I found this picture online, and so now I could go find this one for you guys and throw this in here as well. So a to the m over n. I'll show you where that's at because you should know how to access all your HMH stuff. So right here, if I go to HMH, you would have student resources that you would click on. Okay, and then this is your entire textbook. Okay, and so we are on, let me find the right slide. So here we are on 14.1. Okay, so if I want 14.1, see these unit numbers are going 1 through 10. Right now we are in exponential relationships. That's the unit, but the module is 14. So this is where the 14 is. And then you come right here, here's lesson 14.1. So by doing this, you can get to your student edition if you didn't happen to have the consumable. All right. And so like I pulled this out and put this in the Pear Deck. I defined the same vocabulary. And right here, this is where they're showing that rule. A to the M to the N. Oh, no, that's not it. So here's the one where we have this one. And then it's this one. So right here, I don't know if this is going to let me just throw this in the Pear Deck. It's gonna like me copying and pasting into Pear Deck, which is kind of not as nice. So let's go here, go back. This slide will let me paste. No, it won't. So, you know, as you're doing your own notes, you might want to include this version of it. Okay, because this is what they're referring to when they were saying the definition of a to the m over n, the definition of a to the m over n. So they're kind of working out how you get there, which is a to the 1 over n times m. So they kind of broke apart that fraction. And then a to the 1 over n, well, we already knew this from before. That turned into this, and now you just have this m power on the outside. All right. So it's not letting me add it, which is kind of annoying, but you can change it to look like this. We can actually just write it, right? You can come in here and just use your drawing tool. A to the m over n is equal to a to the 1 over n to the m. So they break it apart, right? And then they throw some parentheses around it. And so we can do that next. A to the 1 over n. So when you guys do your notes, you know, you can screenshot stuff from the Pear Deck. You can screenshot stuff from the videos. You have lots of ways to do your notes. So this turns into the nth root of a. And then this is all to the m power. All right. I like this little picture because it was pointing to everything and telling you what the names of things are. It's the index, the exponent, the radicand, the radical symbol, but this is matching what we're doing here. So they're both good. They're both here. You use both of them. All right. So like I said, this lesson, we're just finishing up, so it shouldn't be too long. We only have one slide left. So I'm going to leave you on student paste right here. Okay. And the next slide here, I want you to try these two problems. Okay. So we have 32 to the 3/5 power. We have 4 to the 5/2 power minus 4 to the 3/2 power. So this one is just a single oops. This one is just a single power that you're simplifying. And this is, you know, you do this one first, then you do this one. Think about PEMDAS order. You want to take care of your exponents, do all that. The last step would be to subtract. Okay, so it's like two problems in one. So do you want me to kind of start this problem with you guys, one of these problems with you, or are you still copying anything that you see here? Because I don't want to move too fast, but at the same time. All right, I'm not getting really any direction from you, so I'm going to give you guys like 3 minutes. Let's go for it. So I only have 3 of you that have started on this. Do as much as you can. If you can't do the whole thing, that's okay, but start it. Even if you're just writing this down, okay? There's no excuse for you guys to not be doing something. Only 4 of you participating is okay. So I got 7 of you to write something. I was hoping for more participation than that. And so if we look at our responses here, I'm gonna go and list layout. So this person did a great job, okay? So look at this, 32 becomes, to the denominator comes the index, the exponent comes out here. We rewrite 32 as, what did they rewrite 32 as? 2, I think they forgot their power right here. So it should be 2 to the 5th power. And then this turns into 2 to the 3rd power, which turns into 8. Almost perfect. You just forgot the little 5 right there. And over here, 4 to the 5 over 2 becomes the 2nd root or squared root. You don't even have to write the 2. All to the 5th power. And this becomes 4 to the 3 over 2. It is the 2nd root, so square root cubed. And 4 is the same as 2 squared. 4 is the same as 2 squared. So you do want to write how you're changing inside. You want to include the symbol. So you should have a squared symbol here and a squared symbol there. But then that cancels out and you end up with this. And you do end up with 24. This person typed some of it, and it is 24. So it's a little hard to type, I know. It's hard to see the steps, but it is 24. And this person wrote it out this way. That's not what you want to do. That's fine. Okay, so yeah, so as you're doing this, it is this number here becomes your index, and you have square root of 32, and then this whole thing is all to the 3rd power. And if you just pay attention to the stuff that's in here, you can rewrite that as the 5th root of 2 to the 5th power. And that whole thing is cubed, right? And so now this 5th root of something being raised to the 5th power, it cancels each other out, and I'm just left with 2 to the 3rd power, or 8. Okay. These ones over here, they're a little bit easier. Whenever your denominator is a 2, then your index is invisible. You don't have to write it, okay? So this turns into the square root of 4 all to the 5th power minus the square root of 4 all to the 3rd power. And then square root of 4, that's 2 to the 5th power minus square root of 4, that's 2 to the 3rd power. 2 to the 5th power is 32. 2 to the 3rd power is 8. And 32 minus 8, well, that's 24. Okay. So with this is technically the end of this lesson. So I'm going to stop the recording.